Hello. What's up? Are you here to learn about atoms, elements, ions, and compounds? Yeah, you are. What up, Miss Lee? We're here. We're teaching you unit like number 3.
Yeah, it's me.
Elements, ions, compounds.
Yeah, you know how it is.
You know how it is.
It's me and Wes.
All right. So we're
Alright.
going to give you a basic rundown of the unit. So look, it starts with atoms, the simplest form of matter, made up of protons, neutrons, and electrons. To start off, we got protons, positively charged atoms that are located in the nucleus, the center of atoms, if you did not know. Then we got neutrons, neutrally charged, they have no charge. Not negative, not positive, no charge.
None of that.
None of that. We don't need it.
Yeah, no.
Nada.
Nah.
And then we have electrons, not positive, not neutron, but negatively charged atoms.
Negative. Like that.
So let's get it going. So atoms make up elements. Elements are the most
Basic.
form of things, basically. Elements. They can't be broken apart, but they can be added together to make
Elements.
compounds. See? Both. We're here to teach them. All right. So along with elements, compounds, and atoms come ions. Ions are atoms that are positively charged or negatively charged. These are called cations and anions. These types of ions are cations and anions. Cations have lost electrons, therefore it has acquired a positive charge. And anions have gained electrons from other atoms, which means they have a negative charge. Precisely. And then Michael's going to take it away telling you about elements and compounds real quick.
What's up, Miss Lee? It's me, and I'm here to talk about elements and compounds. Two of the most important things in chemistry, and we've been using them all year. So, come on. It's like,
Come on, it doesn't get any better than
yeah.
that.
I mean, we're the best group, so.
It just doesn't get any better than this.
Yeah.
This is 100 right here. All right, get it going.
So, basically, a chemical element is a species of atoms having the same number of protons in their atomic nuclei. So, for example, oxygen has the number 8 atomic number. So, every atom of an oxygen will have 8 protons in their nucleus, which you touched base earlier. They're simply one of the most simple substance.
You can't read off the paper either, so
That's
just
not
keep
a
it on your
rule.
lap. Yeah.
That's not a rule.
Okay, keep going.
All right. So they're one of the most simple building blocks of life. You
Yeah,
can't
we
break
touched on that. You can't break them.
Yeah, but
you
that's
can only add
atoms.
them together.
Yeah, but you can't break down an element
Mhm.
into different parts. Only
You
their
can't.
atoms.
You can only break them down
Yeah.
with their atoms.
Yeah.
All right, go off.
Although
Tell us why elements are important. Tell us why Miss Lee would use an element in chemistry.
well, we use an element for everything in chemistry. Every elements
Indeed.
create everything around us, and we didn't need it. So we need to know which elements we're
Like
using.
calcium. Calcium is used in
Oxygen,
milk.
the stuff we breathe.
Oxygen, the stuff we
Hydrogen
breathe.
in the air. So we need to know what elements are which, so we know what's going on around us.
And Mike, a lot of the people have been asking, we've been getting a lot of comments, a lot of reviews, saying we know what elements are, but we're having problems with compounds.
Compounds.
What are compounds?
that kinda
What is their
trips people
purpose?
So basically, compounds are elements, but they're mixed together. So for water, that's H2O. Hydrogen and oxygen put together, compound.
Okay, so compounds are one or more elements added together?
Yeah, precisely.
Indeed.
Precisely.
But the cool thing about atoms, ions, elements, and compounds is they all relate. For example, the periodic table, which shows all the elements, displays each element's number of atoms along with its atomic mass and atomic number. And you might be asking yourself, what's an atomic mass? Like, what is
that?
it?
Wait, what's
An
that?
atomic number. An atomic number is at the top of the element. It displays the number of protons in the nucleus of that element. And the atomic mass is how much it weighs in general. So you might be asking yourself, how does this relate? So on the periodic table where all elements are displayed, it comes with an atomic number and atomic mass, like Michael said. And an atomic number is the same as the number of protons in the nucleus of that single element. So if I had calcium, for example, and we'll pull out a practice problem real quick. If I had, okay, where's the practice problem?
Where's my practice problem?
Is it over there?
Yeah, no, it's right here.
Okay.
Practice
We have
problem.
practice problems. So let's say, right here, I had calcium, right? Oh, hold on, let me like flip this guy.
Can't flip. We'll just have to record it separately. Here,
Okay.
we can just record it.
No, I'll just like put an image up there. So for example, let's say we had calcium. Calcium has an atomic number of 20. Therefore, the number of protons is 20. And the number of electrons are 20 as well. So the funny thing about calcium is the atomic mass is 40. Therefore, if we were to subtract the number of protons from the atomic mass to find the number of neutrons, you would get 20 as well. So it works out nicely. But let's say you had an element that had atomic mass that was 45 and the atomic number was 20, right? So you know the atomic number is equivalent to the number of protons in the element. So you would subtract that from the atomic mass to find the number of neutrons in the element, which would be 25. So this all correlates back to like the simplest point that you need elements, atoms, and ions, and compounds when using all forms of chemistry, whether it's stoichiometry, whether it's, nomenclature, all have elements which are made up of atoms. Some are compounds, which are a combination of elements, and then ions, which sneak in here and there, chemistry, that have positive or negative charges.
And going along with Wes's practice problem and calcium, we're gonna dive more into when these elements combine with each other. So my question is, what is the ratio of hydrogen to oxygen in a water molecule? You can do this ratio with any compound, so like calcium, and let's say like hydrogen, anything like that. So first off, you would write down the formula of water to see what goes into it. So obviously H2O is the formula for water. If you don't know that, you're screwed. So then we're gonna, as you can see, we draw the model of the compound. So what this does is helps you visualize what the compound looks like, so you can kind of get a sense of the ratio and how these compounds are gonna link to each other. And then, so you take a look at your model, which is oxygen in the middle, hydrogen here, hydrogen there, and you realize that there's 2 hydrogen and 1 oxygen.
Lower your voice.
Making a ratio of 2 to 1.
Better.
So 2 hydrogen, 1 oxygen. That is the ratio of atoms in water.
Yeah, so it's as simple as that. And look, the simplicity of the subject goes to show that you will need it in all forms of chemistry. No matter what level you get, you will be using atoms, elements, all sorts of that in all your problems. We're signing out. It is currently like 12 o'clock at night. Hate to break it to you. This has turned into a video log, but we really enjoyed making this, and oh my god, we actually worked hard, so.
Yeah, we did work.
I think we deserve we have
Notes.
so many notes.
Notes.
Like we're raining notes out here.
We did our work. We worked hard for this.
No, but hopefully our project was good. We gave you a clear explanation. We ran through the rubric, so this video is long, and I'm gonna edit it, so it'll probably be way shorter than it actually is. But right now it's like running on 12 minutes, so I'll cut it all out, make it shorter. But Miss Lee, we need the 100 really bad. And if you don't give it to us, we're not gonna do anything because we have no physical power to change it, but we'll cry. And you don't want to see me cry, Miss Lee? Okay. Thank you.
We'll see you.
We'll see you soon.
See ya.